Okay, I think already recorded now. Yeah, let's start our lesson. Yeah, Alhamdulillah, we can see again in this occasion to continue our lesson in competitive programming. And in the past meeting, we already discussed about pretest, and I already give you another contest about dynamic programming. Okay, so we will discuss the contest. But before we discuss the contest, before we start our lesson, and before every time we study, we have to pray first. So don't forget to pray now. Ya. Allahumma inna nas'aluka ilman nafi'an wa rizqan thayyiban wa amalan mutaqabbala. Allahumma inna na'udzubika min ilmin la yanfa' wa min qalbin la yakhsha' wa min nafsin la tashba' wa min da'watin la yustajabu laha. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'alul hazna idza syi'ta sahla. Rabbi israh li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Okay, let me share screen first. And for your information, I already create a group for us, widgets group, to make our contest easier. So I put all contests here. And some of you already joined the group, but another else uh, not yet accepting the invitation. So try to open widgets and see the notification above. Okay, and accept the invitation so you can see the contest in this group. About the past pretest and also in the current contest, that is training one dynamic programming. Okay, there are 26 problems, and some of you already got accepted in some problems. Okay, that's great. And the other, what about the other? Any difficulty about this contest? Or maybe um, you have no time to solve, or another reason? Maybe you can inform me through the chat. Any problem? Yes, Abdullah Isfak. Submit this problem. Okay. What about the other? Hashim Ali. What about you? And Muhammad Saram. Maybe you already solve all the question, all the problem, but just submit here so I can see your progress. Okay. And also Ahmed Imran, how about you? Any problem or difficulties about the contest? Okay, yeah. Yeah, just solve the problems. Okay. Okay, anyway, dynamic programming is a basic concept in competitive programming. So you have to master this concept in order to solve most of competitive programming problem. Okay, let us discuss the problem by one. From problem A, the problem is quite simple. Uh, there are n stones and there is a frog want to jump from stone one to the last stone. But there is a rule that state that uh, from stone I, the frog can jump only to stone I plus 1 and I plus 2. And the cost of his jump is the difference between the height of the stone. So we can solve it by dynamic programming like this. Hmm. Let me show you the code. Okay, wait a minute. Okay, I will show the implementation via this link, so you can directly open this link. Let me change the setting into for text space. Okay, to solve a problem with dynamic programming, we have to do at least 5 steps. There are 5 urgent steps in dynamic programming. First, we need to find the state. The second, we have to find the answer, and we have to find the transition, the iteration. And the last, we have to find the base case. Okay. And the other two, this is optional based on the problem, like backtrack and optimization. Okay, but this 5 step is a must, is crucial. Okay, let me apply to this problem, problem A. For this problem, the state is dpi equal to the minimum cost to jump to stone I. Okay, this is the state. After that, we have to find the answer. That is Cout GPN, because we have to jump, the frog have to jump to last stone. That is N stone. Okay, then why we directly find the answer? Because we have to check if the state is correct. If this state can directly consider the answer, we can get the result by that state, then the state is correct. Otherwise, if we cannot find the answer from this state, so it means this state is incorrect. So the second step is answer before we find the transition, the iteration, and the base case. We have to check whether the state is correct or not. Okay. After we make sure that the answer is correct, so and we know that the answer is dpn, so we can find the transition because we have to know the value of dpn. So we have to know the value of each dpi. For this problem, dpi is equal to minimum between the two cases, because this is in this problem there are two cases, because we can jump one stone or two stones. So there are two cases. We can jump just one stones. So the value is dpi minus 1 plus absolute value of hi minus hi minus 1. And the other case, we can jump to stone. So the value is dpi minus 2 plus absolute value of hi and hi minus 2. Okay, this is the transition. After we get the transition, we have to find the iteration because the transition only compute one value of dpi. And of course, we have to find all value of dpi from 1 to n. So we have to make the iteration for integer e from 2 or from 3. Yeah. Why from 3? Because we, if we see the transition from dpi, we have to access dpi minus 2. So if the iteration start from two or start from one, we cannot access this, because if I equal to one, so we access dp negative one. So it will cause runtime error. And if we start from two, we cannot do this because we have to access H0, while H0, there is no stone here. There is no zero stone. Okay. So we will do a looping start from three. Until what? Until n, because the answer is n. I plus plus. Okay, this is the iteration. Why the iteration put in fourth step? Because we can find the iteration after find the transition and answer. From the transition, we know that we have to start from three, and we cannot start from two and one. Okay. And because from the answer, we know that the iteration have to ended in n, because we only need to find tpn and no more than that. Okay. After that, we have to find the base case. What is it? The base case is any dp that doesn't cover in or didn't cover in this iteration. So because we start the iteration at 3, so we have to find dp1 and dp2 in the base case. What is dp1? dp1, the cost to jump to stone 1 while the frog initially on stone 1. So there is no cost at all. So dp1 equal to 0. After that, how many dp2? dp2 equal to the difference between H1 and H2. Why? Because to jump to stone 2, there is only one way. That is from stone 1 directly to stone to second stone. So the value is absolute H2 minus H1. Okay. After we find these 5 steps, how to implement it in main program. Nah, from this step, we can just copy paste one by one from bottom to top. So just copy paste here and the iteration here. After that, the transition here and the answer here. Okay, done now. So the order is inverted. If we find the answer first, after the transition, after the iteration, and base case, but in the implementation, the order is inverse, is reversed from the base case, iteration, transition, and answer. Okay, and don't forget to input the value. we have to input n and the array h is like this. Okay. Okay. Done for this problem. Any question about this problem? Okay. All clear. And so the point is we have to find these 5 steps to solve dynamic programming problem. Because if we implement it directly, so the step is reversed. So we have to put base case first before iteration. So it is a little bit difficult. But if we do this step one by one in order, so the workflow will be easier. Okay. Next for the problem B, this is still the same story, but now the problem this problem is little bit different. The rule little bit different. So the frog can jump until k stones. So we can jump from I to I plus 1, I plus 2 until I plus k. So we just need to change the transition. This is not just 1 stone and 2 stones. We can jump until k stone. So we have to find the minimum among these values. That is dpi minus j plus hi minus hi minus j. Okay, and don't forget to put infinite here. Or another way, we can put the first value, that is dpi minus 1 plus absolute hi minus hi minus 1. Okay, this is the transition. After that, the iteration, now we can start from 2. But we can also give this condition j have to less than I, because if j equal or greater or equal by I, so the value of dp will be, the index of dp will be 0 or less than that or negative, and that is unintended. So because the iteration start from 2, so the base case just dp1. Okay, we just need to add k here and change the formula. Okay, this is problem B. And most of you or all of you already solved it. Okay then. For that, we move to problem C. Just like the other problem, we have to find state, answer, transition, iteration, and base case. For this problem, the state is the number of j, and what activity we do in that j. Okay, so the state is, let's say, GPI GPIJ is the maximum happiness. Oh, yeah, happiness until J until it J. I yeah, it J. And in that J, we do activity J. Okay. Let's say 0 means swim, and 1 means catch bugs, and 2 means do homework. Okay. So the answer is the maximum between the last day and any activity, because in the last day we can do any activity. There is no restriction about this. So the answer is like this. Okay. For that, what is the transition? The transition will be GPI 0 equal to maximum between GPI minus 1 and GPI minus 1 2 plus the points if we do this activity in that J. Okay, so we will pass it with a I0. Okay. So it's for DPI1 and DPI2, because we cannot do two activity in a row. So if we do activity 1, we cannot do activity 1 in the last day, in yesterday. Okay. This is the transition. After that, the iteration, we can start from 1, and the base case is GP00 equal to 0. In 0th day, we not yet do any activity, so the happiness is 0. If the base case is 0, we no need to put here actually, because the value already 0. If we declare the state here, so the value is initially 0. Okay, then just put the other component here. Okay, then. And don't forget to put the input here. Okay, any question about problem C? Okay, yeah. So, yeah, Hayan says solve this using this way. After that, we move to problem D. This is knapsack problem. So this is little bit um, familiar. In problem D, what is the state for problem D? Because we know that there is some rules about the knapsack. We want to find the maximum possible sum of values, and but we have to make sure that the sum of weight of item at most W. Okay, so the state will be PPIJ, that is maximum value until item E, and the total weight at most J, like this. Okay. So what is the answer? The answer will be TP and W, because there are n items and the maximum total weight is W. After that, what is the transition? In this problem, there is two cases between we want to take item I or do not take item I. If we do not take item I, so the value is equal to dpi minus 1j. Why? Because we want to take, we will discard this item. Item E, item I is discarded. So the item only until item I minus 1. Okay. Just like this. Then what if we want to take item I? To take item I, we have to make sure that J is greater than or equal to the weight of item I. So dpij equal to, don't forget to put maximum here because we want to find the maximum. Maximum between dpij and the value if we take the item I. The value is the value is the I plus dp I minus 1 j minus wi. Okay. So we just need to iterate this transition from 1 to n, and then we have to put the loop again for j from 1 to w. What about the base case? The base case is any index that is not covered by iteration. So this is dp0j and dp I0. dp I0 means we already see some items, but we don't bring any back. We don't bring any knapsack, so we cannot take any item. So the value is 0. After that, what is dp0j? Because there is no item here, so we cannot take any item. So the value is also 0. Because the value is 0, we are no need to put here. So we only need to copy paste from the transition. And the iteration and transition. After that, the answer. Okay. Any question about problem D? And just change the input. Yeah, I think enough for problem D. What about problem E? In problem E, this is actually the same question, right? Knapsack 1 and knapsack 2. This is the same problem. But what makes them different? The difference is only in the constraint. The constraint is different. You can see carefully both this and this. The value will be different. Okay, so different constraint will create a different solution. Because if we use this solution and we will submit if we submit to this problem, it will result time limit exceeded, or maybe runtime error because memory limit, or maybe compile error because we cannot create array this large. So we have to find the other way. That is, we can see that the value is small. So we will take advantage in the small value of v because the value is small. So we can change the state into pbij is the minimum wake until item I and the total value is equal to j. So we will change between wake and value. Why? Because in this problem the value is small while the wake is large. Okay. After that, what is the answer? The answer is the maximum j that the wake less than or equal to w. So we can just use looping from 10 to the power of 5. Why 10 to the power of 5? Because the maximum value is n times vi, that is 100 times 1000 equal to 100,000. Okay, until 0 maybe. And if dp and I less than or equal to w, so we can get the answer I. Okay, and then just break the looping. Okay, this is the answer. So the answer is not always see out dp directly, but sometimes we need to uh, compute it before we get the answer. Okay. After that, we can find the transition. The transition is uh, slightly different in this case. If we want to take stone I, so j have to greater than or equal to vi, and the value is dpi minus 1 j minus vi plus wi, because here we will find the minimum weight. Okay, this is the minimum, not the maximum. Okay, the iteration is still same, but the best case we have to consider it. If there are item and the value is 0, so the minimum weight is 0, is also 0, because just don't take any item, so we will get the value 0 and the total weight also 0. But if there is no item and we want to get value j for j greater than or equal to 0, then this is impossible. So just put infinite here because we want to find the minimum, or because in this problem we just want to find a value that is less than or equal to w. So we can also put w plus 1 here. So we have to create a loop for j equal to 1 until n, or until 100,000, and dp0 j equal to w1, and we don't need to put this. Okay, so the best case is like this. After that, the iteration will be like this. The transition is slightly different, and the answer is not directly from the value of dp, but we have to find the answer this way. Okay, any question about problem E? Yeah, I think most of you already solved this. Yeah, the transition is same. Okay, and then after that, we can move to problem F. In this problem, we want to find the longest common subsequence of two strings. How to find them? We have to state to find the state first. Let's say dpij equal to the longest common subsequence of e first character of s and j first character of t. Okay. So let's say the answer equal to dp s dot length t dot length. Okay. Before we solve, we want to find the string. We want to find the length first. So this is integer. Then how about the transition? The transition is depends on the string s and t. If the is character of s equal to j character of t, then dpij is equal to dpi minus 1 j minus 1 plus 1. Why? Because like this. If there are two string that the last character is same, let's say all of them A, so we can just find the longest common sequence between this and this plus character A. Okay, so dpi minus 1 like this, j j minus 1 like this plus 1 that is character A. Okay. What about if the character is different? Let's say A and B. So we cannot use both of them because the character is different. So there are two cases. We can discard this or discard this because they cannot use both. Okay, so the value is maximum between if we discard A or discard J like this. Discard B, discard from the last character of string S or the last character of string T. Okay, then how about the iteration? The iteration is from 1 to S dot length and from 1 to T dot length. Okay. After that, how about the base case? Base case is PP00 equal to 0 and TP0J equal to 0 also and TPI0 equal to 0 also. Because if one of them empty, so the longest common subsequence is also empty. Okay, so we don't need to put here in our code. So we will start from iteration. And then the transition. After that, the answer. And the input is only toString S and T. Because in the constraint S and T not larger than 3000, so we only put here 3000 plus 5, let's say. After that, let me run this code. Maybe I want to comment it first. Okay, 3 is correct. After that, another sample 2. Okay, correct. After that, this will be 0. Okay. And the last, this is 7. Okay, great. After that, because in the problem we have to output the string, so we have to do the optional case, the extra case, extra step that is backtracking. What is backtracking? Backtracking is we want to know how to get this value. How to find the string? We can do backtracking like this because the answer start from dp s dot length p dot length. So we will create two variable like this. After that, we will backtracking until the base case. Base case is when one of them equal to 0. If one of them equal to 0, then the looping will be finished because we already on the base case. After that, we want to do like the transition to find the track. Okay. If in this state the character is equal, so we will move all ij minus by 1, and don't forget to put the answer. We will uh, we will pass the answer by the character of I. After that, if the character is different, so we have to check whether the value comes from dpi minus 1j or dpi j minus 1. So we have to put branching again here. If dpi j equal to this value, then just I minus minus, else j minus minus. Okay, so the answer is just the out string answer. Okay, let's try the sample. If we see this is reverse, so we have to reverse the answer. Okay, exactly. We have to reverse the answer because we do backtracking. So we walk from back to front. So we have to reverse the string. Okay, it is correct now. Let's try the other sample. Okay. Okay, and this is the solution of problem F. Yeah. You may solve this. Okay, any question about backtracking or about this problem? Or maybe about anything else? If there is no question, so we just move to problem G. What is problem G? If we see the first sentence, we will find the keyword graph. Okay, so this is dynamic programming on graph. DP on graph. DP on graph only applied in directed and acyclic graph. Okay, because if there is a cycle, so we cannot find the value because there will be a deadlock here, just like this. To find the value of this node, we have to find this node. To find this node, we have to find another node. To find this node, we have to find this node again. So just like a deadlock. So fortunately, in this problem, there is no cycle. And the graph is directed. Okay. In this problem, we will find the longest path in the graph. So we can read the state dpi equal to the longest path. Like this. And if we want to solve dp on graph, we have to create depth first search algorithm. Okay. Yeah, I hope all of you already know about this. Do you know about depth first search? Anyone know? Or all of you already know? Yeah, I guess all of you already know because this is a basic traversal in any graph, any type of graph. And then, yeah, at first we want to implement the input and m, the number of node and the number of edges, and we want to input all the edges. After that, we want to store the edges into an adjacency list. We can use vector of integer like this. Okay, then if there is an edge between x and y, we can also reverse the edge. So we can put adjacency list of y push back x like this. Okay. Let's say the definition of dpi is equal to the longest path until node Okay. After that, we want to find the maximum of all dp. So the answer will be maximum of all value of dp. So we have to try every node. For every node, we want to find the answer of dpi, and then we will put it to answer. Answer is equal to maximum of answer and dpi. Okay. Before we use dpi, we have to DFS first. Okay. So DFS, this DFS used to, this is to find the value of dpi. Okay. So we can put current node here. Okay. And just like the other algorithm of DFS, we have to store array of Boolean visited. So we have to know which edge already or which node already visited. Okay, so if we already visit current node, so just return the value. So just return. We are no need to find the value of dp. Okay, and then if this is not yet visited, so we have to set it into true, and then we want to find the value. The value is based from all the adjacent of current node. So the value of dp current is equal to maximum between all dp next plus 1. And don't forget to DFS first to find the value. But if the value is already found, then no need to compute again. Okay, like this. So we can just try to input all of the sample. Okay, 3, correct. And second sample, the answer is 2, exactly. After that, the third sample, the value is 3, and yeah, already all the sample. Okay, this is the solution of problem G. Any question about this problem or any mistakes that I did? If I did a mistake, please inform me. You can inform through the chat if I make bug or anything else. Okay, most of you already got accepted in this problem, and the other just uh, absorb it using this way. Okay, let us continue to problem 8. In problem 8, this is problem grade 1. The problem is quite simple. We are in the, let's say there is a grid and we want to walk from the top left corner to the bottom right corner, and we have to compute how many the number of way, and then there will be some obstacles, so we cannot pass into that location, and also we can only walk to the right or go down. We cannot go left side and also upward. Okay, so there will be no cycle also because we cannot go back. So just like the other problem, we have to find the state. Let's say dpij equal to the number of way to go to cell ij. Okay, so the answer will be dpnm or hw. Okay, after that the transition is we can know the value of dpij from dpi minus 1j plus dpi j minus 1. Why? Because we can go to cell ij from this position or this position. We can just walk here to here or from here to here. Okay. If the number of way to go here is dpij minus 1 and the number of way to go here is dpij minus 1, so the number of way to go to here will be the sum of these two. Okay, and don't forget to add the modulo here. Modulo 10 to the power of 9 plus 7. Okay, like this. After that, the iteration will be from 1 to h and from 1 to w. And what is the best case? We can assume dp 10 equal to 1. Okay. So basically for dpi 0, it solve p0, and this is also solve p0. And the best case is here 1, but to to make this value 1, we can put 1 here. So if we do this transition, the value will be 1, and this is not affecting the other state. Okay, so we can copy paste here. And don't forget, we have to check if this position is obstacle or not. So if in this cell is not obstacle, so we can use this formula. But if this is obstacles, so the value of z is 0. Or we can put else here, dp ij equal to 0. Okay, then we can just combine the code here. Okay, just like this. And then we can see out the value of dphw. And the dp, of course, two dimensional. This is 1000 and 1000. Okay. And also we have to declare the matrix of character here. Okay. Any question about this solution? I think, yeah, almost half of you, or yeah, most of you already solved it. Okay, I think that's clear. Yeah, excuse me, before we move to the next problem, uh, I want to go to the toilet first. So just solve the other problem first, and after that we will discuss the next problem. Okay. Yeah, sorry. I will go to the toilet first. Okay, I'm here. So let's continue our lesson. We are already in problem I, and in this problem we have n coins. Each coins have a probability of pi with heads and 1 minus pi tails. Okay, we have to find the probability we get more heads than tails. So if we want to solve it with dynamic programming, so we have to find the state, and the keyword is we want to find the probability of heads more than tail. Okay, so the state will be dpij, the probability to toss I coins with, and we are having j heads. Okay, so what is the answer? The answer is the total probability that head is more than tails. So we have to check all the possible number of heads. If the number of head greater than number of tails, number of tails is n minus I. Okay, if this condition is true, then the answer added by GP and I. Okay, after that we can just see out the answer. What about the transition? The transition is dpij equal to the sum of dpi minus 1j minus 1 if we get we have head in this coin. So the probability is GI. And don't forget to change it into double because not always integer here. Okay. And also we have to plus it with dpi minus 1j if we have tail here. So the probability will be 1 minus pi. Okay. What about the transition or the iteration? We want to create a looping from 1 until n. After that, we have to create looping from 1 until I. Why from 1? Because if we iterate it from 0, so we will access index -1, so it will be runtime error here. And we start from e equal to 1 because we also access I minus 1. Okay. So don't forget to create the base case. The base case is dp0j, of course. The value is 0, but for dp00, the value is 1. Why? Because if we toss 0 coins, of course we have 0 head. So the probability is 1. And also dp0j, or sorry, dpi0 will be equal to only this, because this is impossible to achieve if we get head here, so the number of head will never 0. Okay, so we can put it here in the iteration and put it here before iteration. So this is the base case. After that, we want to put the transition here and the answer in the end of program. Okay, this is the solution of problem I. Any question about this? 5 of you already got accepted, so almost half. But yeah, okay, Saram got accepted also. Yeah, congratulations. So now already greater than half. Okay, this is the solution. Any question about the solution or about anything else? Okay, if there is no question, we might move to problem J, problem sushi. Only Jawad Akbar already solved this problem. In this problem, there are n dice and and meals. Each dice, there are between 1 and 3 sushi on it. So maybe there is a dish, and a dish with 1 sushi, and a dish with 2 sushi, and a dish with 3 sushi. Okay. Then Taro will roll a die with number 1 until n with equal probabilities. After that, if the die shows number high, so he will eat one sushi in this eye. Okay. If there is no sushi there, so he will does nothing. Okay, so what is the expected value, the number of time of operation until all the sushi are eaten? So at first, we have to know what is expected value. Anyone know what is expected value? Expected value equal to what times what? Okay, anyone know? Probability times value, exactly. Okay, this is the expected value. So in December, for example, in second sample, this is always get 3 operation. So the expected value, of course, 3. While in sample 1, the operation maybe 3, maybe 4, maybe 5, maybe 6, even infinite. We can, uh, it is possible that he always get the empty dish, so he doesn't eat any sushi, so the operation will be so large. But don't worry, the probability will be so small, so not not too affecting the expected value. Okay. After that, if we want to solve with dynamic programming, what is the state? Okay, in this problem, we can make three-dimensional dynamic programming with the state is the expected value or expected number of operation. Expected value if initially there are IDs, um, with 3 sushi and J dish with 2 sushi and K dish with 1 sushi. Okay, this is the step. Then what will be the answer? The answer is dp, the number of initial dish with 3 sushi and the number of dish with 2 sushi and the number of dish with 1 sushi. So when we input the value, we can just count the number of each dish like this. Let's say CNT count 5 like this. So we can just input the number of sushi here and CNTS plus plus. Okay. So the answer will be GP CNT3, CNT2, CNT1. How about the transition? The transition is we can find the formula first. dpijk is equal to, there will be four cases. That is, a case we want to eat a dish with 3 sushi or 2 sushi or 1 sushi or doesn't eat any sushi. Okay. If we eat a dish with 3 sushi, then the probability is I divide by n. Okay, because the tray shows number 1 to n with equal probabilities. So if there are I dish with 3 sushi, then the probability to get this dish is equal to I divide by n. Okay. After that, times the expected value of I minus 1, j plus 1. Okay. Minus 1 because we already eat this, and j plus 1 because if we eat a dish with 3 sushi, so the dish will be 2 sushi on it. Okay, so the expected value is like this, and don't forget to plus it by 1. Why? Because yeah, this is one operation to eat this, and after that there are the condition is like this. Okay, and then plus j divided by n times dpi j minus 1 j plus 1 plus 1, and so is if we eat this with 1 sushi only, dpi j minus 1. And also don't forget to put here if we got an empty dish, so the probability will be like this times dpijk minus or plus 1. This is the formula. Any question about this? Do you understand about this formula before we go to the next step? Any question or understood? Yeah, you may copy paste it, or you also can put comment or edit directly this code if I make a mistake, because in code interview all of you can edit here. Okay, understood about this formula? Or not yet understand? Any question about this? No question. Okay. The other? Any question? The point is, if there are ITs with three sushis and J dish with two sushis and K dish with one and the other dish is empty. So the total dish is N. Then the probability we got a dish with three sushi here is I divided by N. This is J divided by N. Because each dish have probability 1 divided by N, 1 per N. So if there are I dishes, the probability we get any of them is I divided by N. Okay, just like this. After that, if we eat from this dish, so it will be two sushi here. So the number of dish with three sushi will be -1, but the number of dish with two sushi will +1. Okay. So is this case, if we eat a dish with two sushi, then this is -1 and this is +1 because uh, here still one sushi. And if we eat one sushi, then it will be empty. What about if we eat from empty dish? So there is no change because we don't eat any sushi. Okay, any question? Do you understand? Yes, okay. Understand. Understood, I think. Okay, then then after we found this formula, we facing another problem. Here there is a deadlock, right? If we want to find dpijk, we have to know the value of dpijk. Then how to solve it? Yeah, we can just do algebra here. We can move this to the left side like this, and then we can break the bracket, so the value will be like this. Okay, and then because this is dpijk, this is dpijk, so we can combine them, so we can just multiply by 1 minus this. Okay, until this point, any question? Did you understand? Okay. I think it is clear now. Then we can move this again to the right side because okay, the formula is not clear to you. Okay, maybe I can show you by hand. Maybe formula is this formula is not clear, but this is clear, right? dp, yeah, okay. Let's say this is dp A, this is dpp, this is dpc, this is dpd, this is also dpi, dpa, sorry. Okay, to make it simple. So the formula will be, maybe I can use whiteboard or, yeah, I think this is also clearer. The formula is dpa equal to I per n times dpp plus 1 plus j per n times dpc plus 1 plus k per n times dpd plus 1 plus n minus ijk per n times dpa plus 1. Okay. Then we can move it to the left side. So the formula will be like this, and then minus this. Why minus? Because, sorry, because, sorry, how to copy it? Why? Why it cannot copy it? Okay, then I will move directly. We can just move it here. Is it clear? Equal to this. This doesn't change. Okay, sorry. I can just move it here. Okay, then the value will be like this. The formula will be like this. Okay. Okay, after that, we can open the bracket so that don't forget to put this again. Okay, is it clear? Maybe I can move it to the right. So this will be cleaner. Okay, until this point, any question? Is it clear? Okay, yeah, thank you. After that, because this is dpa and this is also dpi, so we can combine them because because this is dpi times 1 and this is dpi times like this. So we can put bracket here 1 minus this. Okay, is it clear until this point? Okay, after that we can move it to the right side again because this is minus, so in the right side become plus, and we want to move here, so dp like this equal to this. Okay, any question until this point? Oh, I missed the variable k. Okay, okay, then become greater. Okay, and then because this is fraction, so we can change it into fraction, and then this is equal to n minus n, so equal to 0, and minus minus 1 equal to positive 1. This is positive j, sorry, positive I, positive j, positive k. Okay, so the formula become like this. Any question about this point? This equal to this. Understood? Okay, thank you. Yeah, sorry, it's already 9 a.m., but maybe we have to finish this problem first. But if there is another lesson after this, please inform me. After that, because this is per n, or we can move dpa here. It is also same. And then we can multiply all the left side and right side by n. So we can erase it. We can erase it also. We can erase it. We can erase it. We can erase this. Okay. The formula become like this. Okay. Any question until this problem? Okay. Understood. Until this point. Okay, understood. Let's continue. After that, we want to move it to right side. So become this is divided by I plus j plus k, divided by I plus j plus k, I plus j plus k, I plus j plus k. Like this, and we can erase this. Okay. So GPA equal to like this. Okay, any question until this point? I think this point is the final formula. So the final formula is PPIJK equal to I divided by I plus J plus K times like this plus 1, then I plus J plus K. This is divided by I plus J plus K. This is I plus J plus K. Okay, formula become like this. Okay, this is the transition. Okay, for the other step, you can do it by yourself. Yeah, you can continue this homework uh, with this transition that I already explained to you. Okay, any question before we finish our lesson? Any question about the formula or about the solution or about anything? Okay, if there is no question, so I think it is better for us to end our lesson because it already 9 a.m. So I hope this lesson will be beneficial to us. Yeah, we have to pray. Ya, Allahumma anfa'na bima alamtana wa alimna ma yanfa'una wa zidna ilma. And we, we will end the lesson with kafaratul majlis pray. Subhanakallahumma bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Thank you. Assalamualaikum warahmatullahi wabarakatuh.